Hello and welcome to the fourth installment of our video series dedicated to the sweep test system software. In the past episodes, we have seen how to set up the software, basic operations like setting the sweep parameters and running a wavelength scan, and how to analyze the data. In today's video, we will look at the optical return loss measurement, a new feature on our software. The return loss of any optical device is the amount of optical power that is reflected back compared to the input power from the laser. This measurement is quite important when characterizing passive devices like interleavers, fiber couplers, or even to check the splice quality. But also it is an important characterization for active devices, as back reflection might damage them or damage the connected components. To use this functionality, the software must be activated. So please check the first episode of this series to learn how to do this. And also we recommend to watch the second episode to learn the very basic operations of this software. So let's get started. Here I have the software running and connected to a TSL 570 and an MPM 210H. First thing, I have to go to scan setting and then select return loss. Here immediately, the software configures the MPM in such a way that the first channel of the module will be dedicated to the return loss data, and the other channels will be dedicated to insertion loss data or eventually polarization dependent loss data. In the case of multiple MPM units connected to your test setup, it will be the first channel of the first MPM that will be dedicated to the return loss data. Okay, next, setting the sweep parameters. So here I have to input the start wavelength, the stop wavelength. I will select 50 nanometers, stop wavelength, 15 nanometers per second. I will keep the step as it is and put 0 dBm as output power. Then I have to configure the MPM. First, I will select just the first and the second channel of the module, and then the optical dynamic range. For this demonstration, I will select a mid-range for the return loss and the top range for the insertion loss data. Okay, nice. Now I click to apply all these parameters and go to the main chart. Now that my system is fully configured, the first thing I have to do is to collect the reference data. For the optical return loss measurement, we will need a coupler. The first branch of the coupler will be connected to the TSL. The second one will be connected to the first channel of the MPM, and the input fiber of this coupler will be connected to the second channel of the MPM. Notice here that channel 1 is connected to an APC polished fiber, whereas the second channel is connected to an SPC polished fiber. We will see the reason very shortly. Now I go back to my software, click on reference, and here my reference data were acquired. Now I have to connect my device under test. Today I am using a CWDM with a filter centered around 1530 nanometers. The COM port of my CWDM will be connected to the input fiber of my coupler. And the channel of my CWDM will be connected to the MPM. And here we see the reason we are using an SPC connector. If we have used an APC connector to the COM port, no back reflection will be detected. Okay, nice. Now go back to the software, click on scan, and here we have our device under test data. In blue are the return loss data, and the purple graph displays the insertion loss data. Now all left to do is click on Save, select the folder, and my file has been saved. And here we have it. Very simple way to measure the return loss using the sweep test system software. So let's summarize today's episode. We have seen that return loss measurement is an important characterization for both passive and active devices. We have seen how to set up the system, take the reference data, and measure the device under test, and how to save the data. The next episode will be the last of this tutorial series, and it will be dedicated to the high-resolution measurement method that allows you down to 0.01 picometer in wavelength steps. Meanwhile, don't forget to visit our website for more photonics solutions.